Yeah, good morning.
Good morning, sir.
Good morning,
Morning,
sir.
sir.
Good morning. So, in yesterday class, I have completed electrical machine 1, which consists BLDC motor, permanent magnet DC motor, stepper motor, and servo motor. So, these all the motors or machines I have covered in the last classes. And today, actually, I wanted to explain about Scott connection. That is what I have told yesterday. But today, I will not explain Scott connection. Instead of that, I will start electrical machine 2, which I told that actually I will cover in the month of February last week or March first week. But instead of that, today only I will take that at least some portion in the highlights I will tell you, and I will finish this thing because it is very simple concepts are there. Only 3 to 4 machines are there. Those things I will cover it in today's class, and tomorrow I will take Scott connection. Clear?
Yes, sir.
Okay. So now today let me begin with unit 5. In that chapter B, that is electrical machine 2. Already chapter A in the unit 5, that is electrical machine 1, which is completed yesterday. This is over. Now let us begin with this one. This electrical machine 2, which consists basically 4 instruments, I guess. Welding transformer, and second one is tap changing transformer, and third one is instrument transformer, and fourth one is this one only, but there is different type, that is precise tap changing transformer. So these 4 machines are there in this particular electrical machine 2. So in this today's class, I will cover this welding transformer, tap changing transformer, and instrument transformer. As you all know, this electrical machine 1 belongs to the motors. It is to the motors part, and this electrical machine 2 belongs to the transformer part, transformer type of machines. Now, from the unit 5, that 40 marks will be asked. So that may be 9th question A and B of 20 marks, and 10th question of A and B of 20 marks. Out of this, you have to choose any one. You have to choose 9, otherwise you have to choose 10, any one. A full question A, B you have to write, otherwise this A, B you have to write. Of 20 marks you have to write. So that is left on you, that which is chapter you are going to select, electrical machine 1 or electrical machine 2, as both the chapters are very easy. As you have seen these motors, that BLDC as well as a permanent magnet DC motor, and stepper motor, and servo motor. Out of this, 20 marks will be asked. And which type of question they will ask? They may ask that explain with neat diagram the concept of BLDC motor and mention its advantages and disadvantages. Like that, theory type of questions will be there. There is no numerical or derivation. Similarly, here also explanation type of question will be asked with the help of diagrams and advantages and applications. So similarly here also. So this is what the pattern of questions which appears in the examination. Now let us move to this electrical machine 2. In that first one, let me start with welding transformer. So this particular concept, let us try to understand what it is in the very simple way. We'll try to understand. Before understanding welding transformer completely, let us try to understand what is a transformer, because it is already 2 months. I guess 2 months back I had covered this transformer. Now let me please let me know that what is transformer. How do you define? Are you getting my voice? Are you getting my voice?
Yes, sir.
Yes, sir.
Hello.
How many times I should ask, ma'am? 2-3 times. That only I should ask. Are you getting my voice? Are you able to hear me? This thing only I should ask. What is transformer? How do you define? You have already studied this. Transformer.
It is an electrical device which transforms the power from one part of the device to another part without changing frequency.
Without changing frequency. Okay. Anybody else? Transformer.
Step up or step down the current
Step down the
voltage level.
voltage level. Only voltage level. See, there are 23 students are there in the meeting, and hardly 1 or 2 people are answering. Others, you don't know transformer only. What is transformer?
A transformer is a static device which transfers the voltage from one electrical system to another electrical system without changing the frequency and without changing frequency and the current.
Current. It will not change the current. It will change only voltages.
Just a little bit changes current, sir.
Then voltage and current together, what you call?
Power.
Transformer is a static piece of apparatus. Static piece of apparatus. Why it is called static piece? Because there is no moving part
Can't
involved
be
in the
moved, sir.
transformer. Like DC machines or any machines, there is a rotating part, rotor will be there, but here no rotating part, hence it is called static piece of apparatus, which which transfer power from one electrical circuit to another electrical circuit without any electrical connection, and keeping frequency constant. So here this transformer transfers the power. Power means which includes voltage and which includes current from one electrical circuit to the another electrical circuit without any electrical connection between those two circuits, and keeping the frequency constant. This is what the transformer. While transferring the power, that power which includes voltage and current, this voltage level may increase and this current level may decrease, or this voltage level may decrease and current level may increase, but keeping power remains same. That is what the difference. So now here in this transformer, what it does, which transfers the power, that power in turn includes voltage and current. While doing so, what it does, which increases the voltage level, that means it step up the voltage. But when that voltage steps up, then definitely current should be get step down, that should get decreased. Otherwise, if it step down the voltages, the current should get step up. In this way, it maintains the power and it transfers from one electrical circuit to the another electrical circuit. The power in this circuit will transfer to the power in this circuit, and there is no any electrical connection. Those are isolated, but magnetically it is linked. It is magnetically linked through iron core, but electrically those are isolated. This is what the transformer. So transformer which transfers the power, while doing so it may increase the voltage level and it may decrease the current, or it may decrease the voltage or it may increase the current. That is what, based on this, what we call step up transformer and step down transformer. So step down transformer, step up transformer means voltage level is higher and current level is lower. If step down transformer means voltage level is lower and current level is higher. This is what we have studied. Now let us go to the welding transformer. Welding transformer. Now, what is welding transformer? How do we define? In very simple words, we can define that the transformer which is used in the welding process is called welding transformer. That's it. What is welding transformer? The transformer which is used in the welding process is called welding transformer. Now let us try to understand what is welding. Anybody, can you tell me what is welding? Have you heard the word welding? I don't want definition. At least have you heard the word welding?
Yes, sir.
Where you have heard? For what purpose? What is the use of that welding? For what purpose it will be used?
Joining two pieces.
Joining of material.
Two metallic pieces.
So welding is nothing but it is the process. It is the process of joining two metal pieces with the application of heat. And it is called welding. It is called welding. What is welding? Welding is nothing but it is the process of joining two metal pieces or alloys together by application of the heat, and that is called welding or welding process. Now in this process, to produce this heat, what you are doing, you are making use of this transformer. Hence that transformer is called welding transformer. Transformer is called welding transformer. Now basically this welding transformer is a basically it is a step down transformer. It is basically a step down transformer. Now I will ask why they will use in the welding transformer specifically a step down transformer they use. Any idea? Anybody? Can you try? In the welding transformer they use specifically a step down transformer for the operation. Why? Anybody? Please try at least, man. You have to try. Otherwise, what you have studied in this whole 4 months? Yes, I'm not getting your voice properly. Yes, anybody else?
High current is required, sir.
Correct. High current is required. That is very good. But now, can you tell me why high current is required?
Melt the welding rod.
Yeah,
Produce spark.
to
To melt the
produce
welding rod.
to
To
produce
produce arc while joining the metal.
to produce the arc. Okay, fine. Whatever you have given answer, that is partially it is correct. Now I will tell you, welding transformer basically uses the step down transformer. Now this step down transformer is a similar transformer which we have seen already in the substations. They use step down transformers to step down the voltages. So what all things it consists? It consists the core, and it consists the windings, and relative some other materials will be there that you have seen. So that transformer tank will be there. In that tank oil will be there, or sometimes fan will be produced for the cooling purposes, and all those things that will be there. But fundamentally it consists the core, and it consists the windings. So now let us see the welding transformer construction. So along with that, other points also I will tell you. So welding transformer. So welding transformer, as you know already. So basically it consists the core, it consists of core, and as it is a step down transformer, this side I will give you supply voltage, so that number of turns in the primary should be more, and this side I will use another color, and step down transformer it is, so number of turns will be less. Before that, what I will do, I will just change the width, so that I want to make some changes here. Fine. Now what we'll do here, there will be a arm will be there, and that arm will be connected to the electrode, and this side another electrode will be there, and that electrode is connected to the another arm. Now I will show this wire in this way. We have to connect. Then finally I use metal pieces here in between. I will place. Okay, now let me write the things here. Applied voltage will be there. So applied voltage is AC in the nature. So here number of turns in the primary is N1, number of turns in the N2 is a secondary number of turns, and this one is the core of the transformer. This is the primary winding, this is the secondary winding. This is the primary winding, this is the secondary winding, and this is nothing but it is called movable arm. This is called movable arm, and this one is called fixed arm. It is fixed arm, and this one is copper electrode. So there are two copper electrodes they have used, and this is also a copper electrode. And these are the two pieces. These are the two pieces to be joined or weld. So this is what the diagram of a welding transformer. Look at this. This consists of core, and this core consists two limbs. On the two limbs there is a windings are connected. This is a high voltage winding, this is high voltage winding, and this one is a low voltage winding. Hence, why it is a high voltage winding? Because number of turns are more and here number of turns are less. So this is a low voltage winding and this one is high voltage winding. Because of that high voltage winding, this side high voltage will be there and this side low voltage will be available. As this side high voltage is there, the current at this side will be lesser, and as here low voltage is there, and because of that current will be higher in the rate. So this transformer, step down transformer, will be used here for the welding purposes, which steps down the voltage. So secondary voltage what you are getting, secondary voltage what you get here, it is hardly up to 45 voltage you are going to get. But the secondary current, whatever I2 here it will flow, that secondary current will be from 100 ampere to up to 6000 ampere will flow based on the applications and based on the applying of the voltage and number of turns whatever you use here. So the current whatever flowing in the secondary, it is very high amount of current is flowing. That is what I told. So step down transformer they are using it. Now here if you see the construction point of view, very good core material will be used so that permeability of the core should be less. Permeability of the core should be high, sorry, not less, it should be very high, so that maximum flux should link. So whatever flux will link now here, that should link with the secondary coil. So flux, so that very good core will be used, so permeability be very high, so flux should be maximum linked to the secondary winding. And the winding which is made up here, primary winding they have used, number of turns will be more, number of turns are more, but it's cross sectional of the winding, cross section of the winding is very less or very thin. So very thin winding will be used here, because the current which is flowing here is very small, means lesser current relatively, so it can carry that current very easily. So large number of turns will be used, but its cross section is very less, that is very thin conductors will be used. At the same time, secondary side, number of turns are less, but it's cross sectional of the conductor, that is what I shown with the thick, so that its cross sectional winding of the secondary winding is very high. It is very high means a very thick wire will be used or winding will be used, so that the current is in the range of 100 or in the range of kilo ampere will be circulating. Hence very thick conductor will be used in the secondary of the winding. This is the constructional feature of the welding transformer. Then this secondary winding is connected to the two arms which are called movable arm and fixed arm. This movable arm moves upward and downward direction, so it can take up as well as it can take down, but this fixed arm you cannot move anywhere, it will be fixed. Now in between you have to place this the metals which you are going to join. So whenever this will comes to this connect to this, so definitely what happens, these are the copper electrode, so current will easily flow. So why copper electrode they are using it? Because conductivity of the copper will be very high, hence that type of electrode they are using it. So maximum current will flow here. As maximum current will flow, and it will flow through this metal also, and there will be some gap will be there between these two joints. Initially there will be some gap. Due to that, at the same time this metal also having some resistance which offers the resistance. Due to that, what happens here, this metal opposes the flow of this current, but still that current will pass some current and it completes its path in this way. When it do this, during that time, due to opposition created by this metal, that I square R loss takes place in this. As this I square R loss is nothing but it is in the form of heat. As this is in the form of heat, definitely it comes to, this metal comes to the fusion point. When it comes to the fusion point, that is a melting point, it will come to the melting point. And when you apply little bit mechanical pressure on that, when you apply bit mechanical pressure on that, then that pieces of the metal get joined together, hence welding process will get complete. This is how welding transformer work. If you have any doubts, now you can ask.
No
Sir,
doubt,
can
sir.
we use our regular transformer as a welding transformer?
Yeah.
Can we use our regular transformer, step down transformer as a welding transformer?
Yes, you can use that step down transformer for your welding transformer. There is no problem. You can use it, but that is based on the how much winding they have used at the secondary level and the current what you are going to produce. Because based on the current only, here heating will takes place. So based on that, this design part you can use it, that regular step down transformer for the welding. And here what we have said earlier, spark will create, but in this type of welding, spark will not produce or arc will not produce, because this type of welding is called, technically it is called resistance welding. This type of welding is called, in this it is called resistance welding, because there are types of weldings are available, and this method what they are using it, I square R method, heat is producing, hence it is called resistance welding method. And what you have explained earlier, that was arc welding. So arc welding, that time they may use some DC generator or sometimes rectifier unit also they may use, so that that AC supply will be converted into DC, and the DC will be used to for this purpose, and they use the some particular other electrode and flux they will be using, and based on that they will connect it and they produce the arc and they do the heating process. But here in this particular method, this method is called resistance welding. And you can use regular normal step down transformer, but you should think of the secondary current, how much current is required. Based on that you can use it.
Okay, sir. Thank you.
Okay, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now in the examination, the question they may ask, with a neat diagram explain the welding transformer and its operation and mention its advantages or application. So these things you have to draw the diagram. It may carry some 2 to 3 marks. Neat diagram you have to draw with the notation, that means the parts labeling and all, it carries some 2 to 3 marks. Then construction of this winding, this core, the secondary winding, about those things, and these things you have to write. So that carries on some 2 marks. Then operation, that means working, you have to explain this heat, I square R, fusion, mechanical pressure applying, about these things you have should write. So that carries some 2 to 3 marks. Advantages, and you mention some, that carries some 2 marks. In this way the marks will be distributed. So this diagram you have to draw it. Is it clear?
Yes, sir.
Yes, sir.
Okay,
Sir.
fine. So let me move to the next concept, that is called tap changing transformer. So tap changing transformer. So let me draw first diagram of tap changing transformer. This is the primary. Then this side it will be secondary. So voltage you are going to apply this side. This is the applied voltage, and this side is the secondary voltage, and this side you are going to connect it to the load. You are going to connect it to the load. Now here, this one I will remove it, this particular part, because I want to draw some other things. Now, what is tap changing transformer? Here, tap changer device will be there, and that tap changer device, what it does actually, which takes the tappings from the winding, and this one so this device is called tap changer, and along with this tap changer we are going to call it as a tap changing transformer. Tap changing transformer, this entire setup we are going to call it as a tap changing transformer. Now before explaining tap changing transformer, let me explain why we required tap changing transformer. Why we required tap changing transformer. Why we required tap changing transformer. If you know the requirement, then you'll understand the process also. So why we require tap changing transformer? Because as you know, here consider that, okay, before that, here substation, generating station, step up transformer, and from that long distance, there will be again a step down transformer, and to this distribution transformer, and to this there will be load. Okay, various loads will be there, and this distribution transformer also step down transformer only, and this is also step down transformers only. Now where it is required, we require this tap changing transformer at this particular place. At this particular place we require the tap changing transformer. Why it is required, that I will tell you. Now consider this transformer, this same diagram I'm going to draw it here. There is a transformer, step down transformer is available. Now this step down transformer, here I will show you internal resistance of this secondary winding of this transformer, and here I will show you some load like bulb load. I will show you. Okay, and this is the voltage applied in a source side. It is source voltage. Now whenever this is which type of transformer it is a step down transformer, like so it is a 220 volt to 220 kilovolt to 11 kilovolt or something like that. Okay, and accordingly this you don't consider that this bulb for 11 kilovolt. Just for example I'm telling you. So there is a load, some loads are connected now here. Now initially what happened, I will show you one switch here, one switch here also. I'll show you one switch, and initially that switch is open. Switch is open. Switch is open means what? Loads are not connected. Loads are not connected. When loads are not connected, here you are going to give the apply voltage, and this voltage will induce same voltage at the relatively proportional voltage at the secondary side. So V2 will produce, which is not called V2. We call it as a E2. EMF induced in this winding is called E2, secondary voltage. Now as there is no current is flowing because switches are open, loads are not connected, current is not flowing here, so voltage available across this load is V2, and this E2 is equal to V2, same voltage. For example, if it is 11 kilovolt, here also it is 11 kilovolt only you are going to get. Okay, but if what happens now? This switch I will close it initially. When I will close this switch, what happens? Current starts flowing. When that current starts flowing, current is flowing through this resistance, and resistance have some value, and because of that voltage drops takes place. When voltage drops takes place across this resistance of the transformer, then this V2 decreases. But what is requirement? This V2 remains the same. Voltage regulation should be, we have to maintain constant. Okay, but as the load increases, this voltage regulations or voltage, second voltage goes on decreases. Now one load is on, so some current is flowing. When you switch on this load also, that another means more current will flow, and due to that more current, voltage drop increases. As voltage drop across this resistance increases, this V2 voltage goes on decreases. Hence we cannot maintain this constant voltage at the secondary side. To maintain this constant voltage at the secondary side, what we are doing here, we are using the tap changing device along with the transformer, and by using the tap changing transformer we are maintaining the secondary voltage. For example, as this voltage is decreases, we have to maintain 11 kilovolt constant voltage at the secondary level. As the load is increasing, current is increasing, and here drop is increasing, this 11 kilovolt become 10.8, 10.4, something like that. It go on changes, but we have to maintain this 11 kilovolt constant. Then how to do it? To maintain this, what we are using here, tap changing transformer is using. Otherwise, in the reverse case also you can consider, whenever there is no load on the transformer, what happens? V2 may go increases more than this E2. That means it may become 11.2, it may become 11.4, or it may become 11.6 kilovolt. And this is also we don't want. We have to maintain 11 kilovolt. So to maintain this 11 kilovolt, what we are doing is we are using the tap changing transformer to maintain the constant voltage at the step down substation. Are you getting why we are using tap changing transformer? To maintain the constant voltage. How, that we'll see later. But have you understood why it is required and where it is required?
Yes, sir.
Okay. Now, next thing is where this tap changing will be connected. Where to connect tap changer? Where to connect the tap changer? That is the question. Now there are, in the transformer, primary side is also available and secondary side also available. So in the primary winding we have to connect it, or secondary winding we have to connect it. This primary is nothing but, I will tell you that high voltage winding is available and low voltage winding is available. So which side I should connect tap changer? Where to connect this tap changer, whether to low voltage side or high voltage side? Anybody, can you try?
High voltage.
Yeah, that is, answer is correct. Now just give me the justification.
Because sir, winding is more, sir, we can change, sir, anywhere.
Winding is
More, sir, in high voltage.
more carrying? I'm not getting.
Sir, the turns are more in high voltage side, sir. So we can change tap
At the
anywhere.
low voltage, we can get only.
At low voltage? So there are two answers. Answer is correct. At the high voltage side, we connect the tap changer. Why? The answer is, there are two answers are there. First answer is, as high voltage winding side is always what? Voltage is high. What about current?
Low.
current will be low, so that you can connect that tap changer easily from one winding point to the another winding point easily here, so that current is low, that magnitude of current is low, so that sparking producing capacity will be low here. So this is the one reason, so that high voltage side is always low current, can interrupt that current for momentarily easily without any problem. Hence this is the one reason why we connected the high voltage side. Another reason is you should go back to your constructional diagram of the transformer. When you go through this constructional diagram of the transformer, we always place first low voltage winding near to the core. Then after that insulation. Here be insulation. Then afterwards we are going to place the, this is low voltage, and after this insulation then there is a high voltage. Then again insulation, then here it is again one more low voltage, here also low voltage, then again insulation and one more high voltage. So here also high voltage. So what is happening here? At the top of the winding, which layer will be available? High voltage winding will be available at the top of this transformer winding. Inside low voltage winding will be placed. So this, in this way, inside low voltage winding will be there, on the top of that high voltage winding will be available. Hence easily you can tap the high voltage winding, hence they will connect it to the high voltage winding only. These are the two answers why the tap changer will be connected to the high voltage side. Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now after this, let me move to the tap changing transformer diagram. Tap changing transformer diagram. This is the diagram which you need to draw in the examination. It is now 10:45. If you want to take, you can take break and you can come back at 11 o'clock. Otherwise, you can stay here. But let me know whether you want break or not. Yeah, please talk. Why you are silent? No, what is yes, sir? Whether you want break or not, in that way I'm asking.
I want break, sir.
Okay, if you want break, then you go ahead and you take break now, and at exactly at 11 o'clock, you just join again. Okay?
Okay, sir.